Hello students, good evening to all of you. So here I'm going to discuss or derive the expression for time period of simple pendulum. So basically, like this is simple pendulum. So this is bob, and that string is basically inextensible and light or means massless string. So this pendulum is suspended from this rigid support. And हमें इसका जो टाइम पीरियड है ऑसिलेशन का वो फाइंड करना है एंड वी आर अज्यूमिंग दैट इट इज doing nearly SHM. And like that, for example, this pendulum at some instant of time is at this position, and after that we'll check for the forces, what are the forces acting on the pendulum. So this is the weight of that bob. Okay, let's suppose it is being displaced by some angle theta, and then this component of this weight is basically mg cos theta, that is mg cos theta, and this component is basically mg sin theta. We'll resolve that weight, and this is the tension in the string. But like we are going to find the or going to write the equation of restoring force, but as you see that this tension and mg cos theta are not going to provide any type of restoring force, or we can say that any type of restoring torque here. So here only mg sin theta is the force which is providing the restoring torque. Then because of this restoring torque, that theta will decrease there and it will come to its mean position. So here mg sin theta is the force that is providing the restoring torque, and we'll write the equation for that restoring torque as torque is basically force into perpendicular distance. So we can write this force as mg sine theta, and perpendicular distance, like this is the point about which that is oscillating. So let L is the length of the string, so length of the string is basically the perpendicular distance. So it is torque is mg sine theta L, and that is a restoring torque, so we'll put a negative sign there because the torque is basically reducing the angle of that uh, bob with that vertical. So tau is or torque is minus mg sine theta L. But as we know that, like for a restoring force or for to perform SHM, the torque must be proportional to theta. So we can say that if theta is small, then we can say that sine theta will give results that are approximately equal to theta. So the expression can be written as tau is equal to minus mg L into theta for some range of angles that like up to 20 degrees. This sine theta and theta will give approximately same answers in radians. So tau is mgl theta. This is the expression for that restoring torque there. Or students, we know that from the laws of motion, Newton's laws, that torque can be written as I alpha. So alpha is the angular acceleration and I is the moment of inertia. So that is also the equation for that torque. So tau is equal to I alpha. So here we can relate these things there, and this is I alpha is equal to minus mgl theta. So from here we can get the expression for alpha, that is minus mgl theta upon I. So I is the moment of inertia, like this is a mass m and that is oscillating about this point. So its moment of inertia is simply ml square, that is the moment of inertia. So we can put here that is minus mgl theta upon I, and in place of I we have to write ml square. So यहाँ m से m cancel हो जाएगा. We are getting alpha to be minus gl theta upon L square. Again L से L भी cancel हो जाएगा. So we are getting minus g theta upon L. That is the expression for alpha. And then we simply compare this alpha with the alpha of that SHM. Okay, equation of acceleration for that SHM. So that is simply alpha is equal to minus omega square theta. That is the equation for that acceleration. So alpha is minus omega square theta. Sorry, this is theta minus omega square theta. Then we can equate these two equations and get answer for our omega. So from here, when we equate that, that is minus omega square theta is equal to minus g theta by L. So from here we can simply get omega is like root g by L, that is value of omega. So that is the omega for that simple pendulum, and after that we can easily get our expression for time period. So time period, as we know that time period is 2 pi root inertia factor upon that spring factor. Okay, so we'll put the values there. So time period is 2 pi inertia factor upon spring factor, or otherwise, you know, already derived the expression for w omega, so we can directly put the values there. So time period is 2 pi by omega. So we have derived that omega, so we'll put it as 2 pi omega, and the value of omega is simply root g by l, and we can obtain like 2 pi root l by g. So that is the expression for this time period of simple pendulum that is performing the SHM for small angular displacement. So it is 2 pi root l upon g. Thank you.